Number 60 in this series where I am programming an NES game live on Twitch from scratch. This is I should say that I apologize for the gaps in the streams, but sometimes it can't be helped, and I was pretty sick and stuffed up last week on Thursday. Still a little congested. I figured nobody needed to be listening to me sniffling through coding and assembly, so I figured I'd skip and get some rest and hopefully feel better in time for today. And I'm doing okay. Still recovering, but I think the worst of it is over. So I figured we'd catch up on what's going on here and take care of some of the enemy rendering stuff that we're doing. Now, without having looked at the files, I was thinking that we needed to sort the objects that come in from the map in order to ensure that we are only examining the list of enemies that we're spawning in an efficient way. So what was happening is right now in our code, what I can't remember. That's the game logic for it. Where did I actually add? So I got rid of the code to. Originally, we were adding enemies by by just simply pressing the A button. So there's our new subroutine. Okay, so it's what it's doing right now is it's looking at, we're writing out how many objects are in the map, and we are starting from the beginning of that list and iterating through that list of objects and trying to determine which object we should spawn. Right now we're just assuming that they're the flyby little square enemy because that's all we've got. This guy, but eventually we'll want to do more, and right now it's kind of dumb the way I've done this just because I was trying to get it working when we first implemented this, where it's just looking at the list and simply saying, okay, if the camera Y matches the Y position of the object in the list, then spawn the object by doing this call to add flyby. And the problem with that is that it's pretty inefficient, because if we have a bunch of enemies in the map like we do here, I mean, there aren't that many, but there's enough, right? Then we're going to run into a situation where we're unnecessarily checking all of these objects every time. So I had talked about doing this in the previous streams. I'm going to change this to add the bumpers at the end so that we don't scroll all the way off the end. I mean, technically, I guess we can still navigate through those bumpers and not crash into it, but it'll be less likely this way, and then we won't see the weird garbage characters that we're loading. So what I was saying though was there is, and we still have to manually remove this from the exported list of objects, but what I was saying was I thought originally we were going to have to sort this list. It turns out it's actually already sorted. It's just sorted backwards from what we want. It's sorted top down, which makes sense if you think about the way that these maps are generally used. They're used for something like a 2D tile map that has either a top-down view or it's kind of like a three-quarter view where stuff that's in the back is behind stuff that's more towards the front of the map. So before we go through the process of messing with this too much, I want to see, yeah, so this already has a manual. There's no bottom up. That would have been handy because then we wouldn't have had to sort anything or reverse the order or anything. All right, so let's leave it at this. So basically what we want to do is once we get our enemy order loaded, which we're already doing, we just want to flip the order of the enemies, which is pretty simple to do. The only situation we might run into is that we don't have to flip one because the list is odd, and so we have a single item left in the middle, versus if it's even, we're gonna have to swap all of them. So not really much of a sort problem, which is too bad. I was gonna talk about, well, I don't know if it's too bad. I don't know that anybody wants to sit and listen to me talking about sorting algorithms, but we were going to implement some simple sorting stuff here, just for kicks. But turns out we don't need to. So let's take care of this, shall we? So in the load map call, we are iterating through all of our stuff that's part of the map, and we are getting to our object group, and then we are looping through to determine how what the actual enemy objects are. Let's see here. So the object count, yeah, so the object count comes from the size of the array that's in the JavaScript object notation. So sorry, I'm doing a bunch of scrolling here. I always feel like that disorients people, but we have this object property here that's an array, so it gives us the size. So we know how many objects there are, and we just loop through that. So now, once we have that, all we have to do is reverse the list of objects, because we're going to get them in order. And let's see. So how should we handle this? What's the easiest way? I mean, I think the easiest way is probably we have essentially two indexes or indices. We have I and J, and we're starting at either end of our loop. Right, and so in the loop, we don't want I and J to be equal. Well, actually, we want I to be less than J. So if I is equal to J, we're done. Or if it's greater than J, we're done. I didn't start the editor here. So, right, because if we have our list, let's say we have, right, and we have I starting here and J starting here, and then we're going to increment I in this direction, and J is going to get decremented. And so if I and J both end up here, we don't need to do anything. If we have, this is what I was talking about before, if we have this where I starts here and J starts there, and I goes past J, right? So now that I is greater than j, then we're done too, because we don't want to re-swap those items in the list. So that's pretty straightforward. We just need a we just need the a temporary map object that we can use for our, okay, and so that's just a vector 2. And so what we're going to do is we're going to mem copy map objects I. We're going to copy that into temp, right? And that's a size of vector 2. What's wrong with map object? Oh, map object, not map objects. Yes. So we're going to copy that into temp, because then the next thing we're going to do is we're going to copy. This is just a simple swap, right? There's nothing complicated about that. We're just copying j into I, and then we're copying temp into j. And then that should give us the reversed order, right? If I didn't screw that up, let me think, is there a better way to do that in terms, I mean, we got to copy the whole vector, so I don't think we know that I can think of anything that's a faster way to do that swap. So let's take a look at what that looks like. So we have 20 objects and I is at 0. So we're starting at the 19th, the 20th element, which is index 19. And so map object I is that, temp is that, map object J is that. So what should we should end up with is map object I will be 141, 20, 159. So they'll switch, right? So I will copy into temp, then J will copy into I, and then temp will go into J, and that should be it, and it just keeps doing that. And what we should end up with at the end of this is just the reverse of what's in the file, right? So the first object here is 141, 21, 59, and that would be the last one here. 141, 21, 59. The next one would be 127, 21, 75. $127, 21, 75. Yeah, that looks good. So that reversed it. And that's really all we need to do on the asset tool, because now it's in the order we want. So we export it. And now we have all our newly exported stuff here in the export folder. So let's copy that all back into here for us to build with. I mean, I guess we could change the assembly code to reference the export folder, so we don't have to keep moving it around, but it's all right for now. So let's take a look at this now. What happened? gamepad isn't working here. Trying out, I just got this 8-bit DOE SN30 Pro. Thought it would be cool to try that out. It just, is it just the input is messed up for some reason after I changed it? Alright, that's fine. Oh, I guess it switched it to Joypad 1. That's weird. I'm not sure why Windows decided to do that, but okay. Make sure the enemies are still showing up correctly. They are. So that's all spawning correctly. And we should get our little barrier at the end. There it is. Okay. So that's all working. So now we need to change the way we handle spawning the objects. So right now what we're doing is we're starting from 0 every time and then going up every time from the very beginning. And what we want to do is we want to keep track of where we were, because it is now sorted properly. So once we've spawned the item in the first item in the list, it will never show up again, and we can move on to the next one. So enemy position. Okay, JSR add. There it is. All right, so compare with level object count. That's the other thing. We don't need to do this for level object count. What we need to do is we need to simply increment the enemy position, and we're done. Short of there being, well, so there could be 2 enemies on the same position. So I guess we could increment it, but let's do this. So we're gonna load. What were we using? X. So that's the level object count that we're gonna compare it against. So this is enemy position. This also starts at enemy position, which is our offset for the level object data here. Well, so do we need to? I'm gonna think about that. Yeah. Oh, okay. Because right. So the enemy position isn't just the Y value. It's what? It's the X position and 2 bytes for the Y value. So it's 3 bytes. So we'll load that, and then not rotate left, with ASL, arithmetic shift left twice. So we're doing a shift by 2, and then we're clear carry and add carry. So the reason we're doing that is because you can't use bit shifts to multiply by 3 directly, you have to multiply. Sorry, that was supposed to be 1 shift. You multiply by 2 and then you add 1, right? Because it's effectively the equivalent. And that's a trick to use the bit shifts to get part of the way, and then you add on the rest for non-powers of 2. So that gives us that, and then transfer A to Y. So that's our Y position now correctly. So now we want to compare X to the level of objects, level object count, and if we're done, then if it's the same, we're done, right? If it's not, then we're going to look and we're going to compare that, and then that's it. If it's not equal, it's branch of equal to that. Otherwise, skip spawn object, and we're done. We can actually say done with objects. And yeah, so let's walk through this. So we have our enemy position. We're loading it to X. We're then calculating our Y by taking the enemy position, multiplying by 2, and adding it again to get the offset. Since the position into the memory is there are 3 bytes. There's the X and then the 2 Y bytes. Since it's a 16-bit Y value for the world position, we do our comparison against for the enemy position against the level object count, and if we're at that point, then we're done. Oh, you know what we didn't do? We didn't increment our enemy position. We got to do that in a second. Okay, so if we compare it, it's equal, we're done. Otherwise, get the X value, store that off, get the Y value, compare it to the camera's low byte Y position. If it's equal, then go to here, because we're not done with the object yet. Then get the next Y, and if we compare those two, right, the camera Y high byte and the Y, and they're equal, then we want to add the flyby. Otherwise, we're done, and we want to jump to done with objects. So here, if we're going to actually add the thing, what we want to do is we want to increment enemy position, because that enemy has been spawned and we don't need it anymore. And then we do our subroutine to add the flyby. What did I break? 886. ASL. Arithmetic shift left. 1. What? Oh, right. You can't tell it. Sorry. You can't tell it how many shifts to do. You just do 1 shift at a time. All right. So that's that. And so now once we... Okay, so this is good. This is good as long as we don't have any enemies that are on the same Y position. So if we look... What I mean is, right now we're just assuming that once we get to the end here and we've spawned the enemy, we're done, right? And we're not, if the next object has a Y value that's the same, we will essentially no longer spawn any enemies, because at that point we check the one enemy, the Y value doesn't match the camera Y position, and we will be stuck with no more enemies on the level. So what we need to do is we need to, well, I mean, there are 2 ways you could address this, right? You could say, well, we'll just make it so that no 2 enemies can be on the same Y position at the same time, which, I mean, I don't think that's a great idea, because you might need that for some design reason, you know, as you're working on the game, you might decide you want to do that. So I think the best option will be to, once we spawn the object, we go back to the check to the start here, let me think about how we would handle that. So we would need to increment y to the next position. X already, let's see, so X is not incremented because we normally are only just checking the one object, so we would want to increment it in order to get to the next enemy position that makes sense here. So all we would really need to do then at that point is to jump to check objects. And then once we're done, so let's say we have 2 or 3 or 4 enemies on the same line, what'll happen is we'll spawn the enemy in the subroutine. We will increment the Y to the next position, which has the X value in it for the enemy. We'll also increment the X register so that we are keeping track of how many, what the enemy position is, so that we don't go beyond this level object count. And then we're going to jump back to check objects. It will check the level object count. I suppose we could... I'm going to leave it here. What I was thinking is I could check the X down here to see if we've already if we're already at the level object count and we just want to go to done with objects to avoid jumping back. But ultimately, it adds more instructions. Doesn't really save anything. So that's that. So then we'd go and check the next one. And if the Y position doesn't match, we'll come back to it later because the enemy position will have the next enemy loaded in. If it does match, we'll spawn it, go back. One thing I wanted to check was to make sure that add flyby is preserving X and Y. So let's see, X is transferred to A and pushed, and then we're pulling A and transferring it back. So that should be good. We didn't want to have a problem where we're jumping into this subroutine and then we're clobbering our X, and that's going to break the code. So let's see how that goes here. I have to reload that. Now, one of the problems we had was, let's see, well, it's not adding the enemies in. So let's talk about that problem before we talk about any other problem. Actually, you know what? I want to rename this to enemy index. Enemy index, because that's it's not really the position of the enemy on screen, and that might be confusing. It's the index in the loop of processing the enemies. All right. Not that that was super important to do, but I try to name things in a logical way where they're not confusing. All right. Let's take a look at this. So we're going to go into this loop. All right. So enemy index is 0. Level object count is 14 hex, which is 20. So that's good. That's what it actually is. Compare X level. Okay, we're not done. So Y is going to be 0, hopefully. Oh, it's... Oh, crap, it's not. For the first... Oh, actually, no. Enemy index is 0, so it shouldn't have... Okay, no, that's fine. Sorry. I don't know where that came from. So, all right, so we're going to load the X position and store it in temp, and that's stored. We're going to increment the Y, and we're going to load the next value, which is part of the Y value for the 2 bytes there. So let's go take a look at that. So level object data is at 95. And remember that that's the pointer to the location, so it's is it F3B8 or B8 F3? No, I was right the first time. F3 B8. No. Why did it not go? F3 B8. There we go. So that's the X position. That's the Y position, which is 86F. So 86F, the camera position right now. Let's see. Camera is at 68. So the camera is currently at B9F. And we are comparing it against, yeah, so that's not, we're not there yet. Let's put, let me see. So if we compare branch of equal, otherwise jump to done with objects, increment this, compare branch of equal, otherwise done with objects, this. Okay, so let's see if we get to this at some point soon. We do, okay. And does that make sense in terms of how the level is structured? Yeah, so we have our blue strip there, and then that strip, and then there's this. And so yeah, so we're getting to the point where we should have a blue strip with the enemies. So we're close. So now we're loading in and comparing the camera data there, and we are at B6F. So we're not quite there yet. Huh. So now we're getting into the situation that I said, where if we make a mistake or hit something problematic, we don't spawn any enemies. So let's see what happened. So surprised didn't increment that. That's weird. Why is it not ever hitting it again, except for the first one? So enemy index is 0. We're not incrementing that at all. Y is still okay. So coming into it, Y is 1 here, which is fine because that gives us our second. Yeah, which is correct. That's the second, the upper byte. I mean, we're comparing that, and then we're branching if equal. Where is the problem? The problem, I guess the question is how, why, I'm not sure what the question is. The question is, why is it hitting this breakpoint at B6F, but we are currently at, if we look at 95, F3B8, 86F. Okay, so we have 6F is what's matching initially, and then, but we're at B and not at 8. Which would make sense because we're iterating through, but so then it should should come through here again when we... Am I just being impatient? It's possible I'm being impatient. Let's see if it hits that breakpoint again. It does. Now the question is, we're at 8.6f. Oh, maybe I was just being too impatient and it is hitting the right point. Let's see. So we compare 8 with what's camera's location again? 68. A6F. Oh, I wonder... I wonder if I have the wrong... Oh, you know... I wonder if I didn't... 29, 27... I wonder if I didn't export the file again after making the change, because 29, 27 is the higher value, or no, it's even, that's odd, 29, 27 isn't even a value in the map? Well, that's bizarre. F3B8 6F 8.6F is 8.6F, not 4, 2159. Okay, no, that's the right value. So what gives? Is the camera not moving correctly compared to what it should be? This is... Oh, really? 2156. Wait a minute. Okay. Obviously didn't really think about this very carefully. Or I shouldn't say that. It was a simple mistake to make. We don't have to do this rearrange. Partially, we don't have to do this rearrange. It's actually in the right order in the JSON file, which is strange, except that it's strange, but it's not. It's strange because I was expecting it, when it said top down, to be meaning top down like from here down, but what it actually meant is from here down, because this top corner here is 0, 0. So it's actually in the exact order that we need it to be, which means we didn't have to do any of that reversal. Not that that was particularly complicated. The harder part was changing the assembly code to deal with it in the appropriate way once we had it in the order we wanted, which, surprise, it was already that way all along. So, bully for us. All right. Replace those and rebuild and relaunch, and that should fix the problem. The problem being nothing. Just silly. A silly mistake. And then, okay, cool. So it's going to spawn the enemy now. Let's... Now what? So those two spawn properly. Is it not sorted? Or it's not exactly sorted? What is the deal? So 2900, 2896, 2899. No, it's not exactly sorted. Why would you partially have it? Is it just based purely on... It's not 100% sorted. Why isn't it 100% sorted? Can we make it 100% sorted? What is it sorting by? 2896... 2900, 2896, 2899, 2897, 2898, 2898, 2895, 2610. So it's partially sorted, but not 100% sorted. Really tiled. Is there any way that you can help me out here and just be fully sorted? Let's see if they have anything in their manual here. I'm not sure if it's ironic that searching for something called sort is not turning up a fast result. I guess it would be more ironic if I were searching for something like search index. All right, let's try this way. Tiled map editor sort objects. No. It's just kind of all whatever order it wants to put it in. That's roughly sorted because of the way that I've put them in there. Okay, well, let's talk about sorting. Sorting is one of those things that generally you don't have to implement yourself because your programming language has a library that does it for you. I don't believe C does, though. C++ probably has something in the standard library, I believe, that they use to provide sorting, but we are not, strictly speaking, using C++ here, so how do we want to sort this? So sorting in general is one of those topics that if you've never taken a computer science class, you are probably not bored of talking about or thinking about for potential interview questions, because it's one of those things that interviewers love to ask, because it's not something that you do every day, and it kind of covers a range of topics within computer science that are interesting, I guess, in terms of performance and trade-offs and complexity calculations. And someone is saying standard sort in C++. Yes, that's what I was thinking of. Qsort for C. Is that really what it is? Now look at that. I don't think I've ever used Qsort in C. Let's take a look at what that looks like. It's not totally RSX. Thank you for reminding me of Qsort for C. I don't know what's up with the internet today. It just seems like it's been slow in general. Let's take a look at what Microsoft has mangled Qsort into. We'll talk about what quicksort is and why it works well, and complexity and stuff like that. But well, crap, if they've got it, I don't know that I necessarily need to be implementing it myself. And this is what I was talking about a little bit earlier in terms of like interviews. You know, people ask you to implement it or talk about it in detail, and most of the time you don't have to do that because there's something in your programming language that has it there for you. Not that it's not important to understand. It's extremely important to understand why you choose something like quicksort over other sorting methods. But so real quick, no pun intended, quicksort, basically you are kind of subdividing up the work. You're choosing a pivot point and you're shuffling objects that are less than this pivot element over to the left hand side. Same thing, things that are greater go over to the right hand side, and then you further subdivide, and you keep doing that until you are done with the sort. And so dividing it up and choosing the pivot element, and then continually kind of narrowing it down, eventually you get a sorted array of objects. And it's called quicksort because it is generally quick. It is in general a pretty fast sorting algorithm. Big O n log n, which if you're unfamiliar with the notation here, you should read up on it. But basically it's if you have n elements in your array, you don't want a sorting algorithm that's like n squared or n cubed, because that's really terrible performance. You also similarly don't want 2 to the n, because as n gets larger, that means the complexity gets larger. The amount of operations you have to do to sort your list becomes larger and larger. And so something like a bubble sort, which is really naive and simple to implement, where you go through your whole list and you say, okay, here's my first element, and let me find where it sits in, you know, in this array. Okay, here. And then I have my second one. Where does that sit? Oh, here. And then it's called a bubble sort because elements tend to bubble out into their appropriate position. The performance of that is terrible because it is comparing the elements over and over and over again, whereas something like quicksort here doesn't have that problem. It is, I mean, it can degenerate into a slower sort, but basically it is, you know, on average, a good sort to use. A better sort to use in some cases is merge sort. So quicksort is good because you can do the sort right in location. Merge sort requires some additional storage usually, but the nice thing about it is better over larger sets of data and can also be parallelized better. I'm not going to get into how, but if you have your data here it's literally what it sounds like. You're splitting it up into smaller sets. So let me actually do something that's a manageable size that I can draw. So let's say we have these elements here, right? We would split this up into 2 sets here. How many elements do I give? 4, 7, right? So we have our 4 elements here and our 3 elements here. And then we split this up into 2 elements and 2 elements and 1 element and 2 elements. And then it's called a merge sort, because then once you've split the things up and you've got them here, you merge these 2 up, comparing the elements in here and getting a new sorted set of 4. Same thing here, you get a new sorted set of 3. And then once you get these here, again, you do the comparison of these elements and you get your sorted set of 7 back. However many I drew here. And again, it's handy because you have a way of splitting up work for parallel processing. If you can envision this being a large set of data with hundreds or thousands of items, there are a few things you can do, right? You can keep the content stored in different files, for example, where you're performing your merge on different sets of data files across different nodes, where they're splitting and remerging parallel across multiple cores on a system, and then dumping that back into a file that then other systems are merging back in as those sets are being completed. It also has a complexity of O(n) log n, which just means that the complexity as n approaches some large number is n times the logarithm of n. So better than quicksort in terms of overall stability. Quicksort sometimes performs a little bit better, but depends on number of elements and the use case. And I'm summarizing heavily here since we spent a bunch of time based on a dumb assumption that I made with the way tiled works. So C has quicksort. We're going to use quicksort. It's fast enough for what we're doing. We're doing a small number of elements. It's going to work in the in-memory storage that we have, which is good. If we were doing a larger set of elements, like something for, I don't know, a huge map of a game, or like an MMO where there's, potentially gigabytes of data, or storage data in a database or something like that, we would be using a merge sort most likely, or some other variant. Quicksort will be fine for what we're doing because it is generally performant enough, and we don't need to do all that much. I don't think we're going to have more than 100 or so items on our map, so it should be fine. So let's take a look at the documentation here on how this works. So, all right, so base is the target array. So that is the array that we are operating on. We are giving it the number of elements, the element size in bytes. So that would be the size of the vector. We are passing it a function for the comparison, because this will operate on any type of object, so it doesn't know, or any type of memory, so it doesn't know what the memory represents. It just knows that we have an array composed of bytes of memory that we will then perform a comparison on, and then get a comparison result that says it's either greater or less than, and that will, similar to how any C++ or object-oriented sort algorithm tends to work, where you're supplying your objects, you have to give a compare operator, well, in an object-oriented programming language, you would overload the comparison operator. Generally, and here you just pass a function to do it. Same context, same basic idea. So a pointer to the context, which can be any object that the compare routine needs. Okay, so we don't actually need that for anything in the compare operation. So we're going to do qsort s, and it will be our map objects. right? So that's our array of objects. We have object count objects. They are the size of a vector 2. Compare map object will be our function name, and we have no context to pass it. Is this not map? I keep doing that. I keep calling it map object with an S. Okay, so now we need to write that function for the comparison, which is pretty easy. What we need to look at is what compare returns. So if element 1 is less than element 2, then we will return a less than 0 value, so -1, right? If element 1 is the same as element 2, we return a 0, and if element 1 is greater than element 2, we return a value greater than 0. So it's an int compare map I think I called it compare map objects. Compare map object. I don't know why I'm having a problem with plurals lately. Objects, let's call it that. So stop. So here's our context, which we won't be using. Element 1, element 2. All right, so we're just going to cast these over to our vectors. Right. All right, so we want to sort it. Let me think about that. So we want to sort it in order to have we don't want it to be lowest value first. We want it to be greatest value first. So yeah, so what they're talking about here is if we wanted to sort it in ascending order where the values of y are getting bigger, we want it in the reverse order. So what we're going to do is we are just going to return if v1y is greater than so if v1y is greater than v2y, return -1 again, because if we returned if we did it in this based on this description, we would end up with it sorted in ascending order, which is not what we want. If it is less than, we want to return 1, otherwise return 0. And I need that to be properly pluralized. And what's end pointer void void void? Oh, int pointer. No, sorry, it's not an int pointer. It's a pointer to an int function that has a void, and a void. Cannot convert argument 4 to core CRT. What? Okay, what is the problem? What is that actually? Void. Oh, to const voids. Okay. All right. So now this quick sort will sort our objects in descending order if I did this right. So let's take a look. And it's not totally RSX. Thanks again for the pointers there. I appreciate it. Because it's been a while since I've worked in C, and I forgot about those, or the specific name of the C++ one. Anyway, map object. So that's 2900, which should be the. Where is this? Yep, so it's 2900. So the next one would be 2896. Oh no, it wouldn't, because we're actually sorting it properly now. So 2899, and it looks like I did this right. 2098. Okay, cool. So we've exported that. And let's rebuild that and go back to Messen and restart. And now hopefully things will start spawning in the appropriate order. There we go. And we shouldn't have any issues. Close the debugger here. Shouldn't have any issues with me firing. Oh, we still are having some. It's interesting. I wonder why we're getting these weird issues with the map loading like that when. Seems to be consistently the same kind of Are we running out of entities and I'm not properly protecting against that? That's strange. Is that in the So that's in the PPU viewer, so that actually got changed over here. I wonder how consistently I can make that happen. When I'm not dying. Interesting. I attributed that to too much time being taken checking for enemies spawning, but it seems to be more related to spawning the bullets that the player fires. And I wonder if I'll have to figure out what's going on there. I don't think it's going to be tonight. We're at just about an hour. And while I could spend probably another couple hours troubleshooting this, what I'm thinking I want to do is call it for the night, just because I'm still congested and I don't want to be up too late. I have some other things I want to look at for tonight that are not NES related. And honestly, part of where we're at now at this point is that we've got sort of the core of the engine working, and I've got to think some more seriously about things like design of the game, which is The harder part, and not something that makes sense for me to be sitting here kind of debating on stream. I think it would be better if I actually had a sense of specifically where to go with the design. I have some ideas that I've kind of roughly worked out, but they're not done enough that we can start implementing them. I think I've talked about it a little bit. One of the things that I want to be able to do is kind of add abilities to the ship, and potentially even have some areas where you go behind the background, and so the ship would go sort of dip underneath barriers. I'm not sure if that's a special ability or that's just something that the ship can do. That's something that I have to kind of work out and playtest a little bit before we implement that here. And I'm still kind of waiting on some of the art stuff that I'm hoping to get here from the artist that I started talking to. So hopefully that will also potentially kind of improve the way the game looks, and kind of make it a little more exciting to start building levels. And then the last thing is I'm debating on whether or not I want to roll back MMC3 mapper usage in favor of something a little bit simpler. Originally I was thinking we would have this status bar on the bottom, and yeah, we got it working and it's cool, and it, it's fine, but I'm debating whether or not we actually need it. And if we don't need the status bar, then we don't need to be using mapper MMC3. We can switch to something else. The upshot of that, not that it 100% matters, because it's not something that we need to be even considering right now, but different mappers are more expensive to produce, and so if we were to want to make this an actual cartridge and we needed to use the mapper, the cartridge part is actually more expensive. And I'm trying to keep that in mind, because the goal is eventually to finish this and make this something that's actually playable, and you get a cartridge, and it's kind of cool to have. But it's we're still pretty far off. But we've got our sorting going. We've got our enemies spawning properly now. It's being handled more efficiently, which is good. Have to figure out why the name table is being corrupted at times when I'm firing the bullets. Still bothers me a little bit, but we'll figure that one out eventually. I'm not worried about that. I just kind of think it's going to be a much longer stream. So with that said, for now, we're good. I'll see you on Thursday for sure. Thanks for watching the stream. Sorry they've been short, but we're kind of hitting some points where we can accomplish a little bit more in shorter streams, as I kind of understand what we are doing more, and we can kind of keep them concise rather than 2.5 or 3 hour streams where I'm pulling my hair out trying to figure out what's wrong and what's not working. So see you Thursday. Thanks for watching. Have a good night. And yeah, of course, if you have any questions, you can find me on Twitter at Claravis. Feel free to post questions on the in the comment section of the recording uploaded to YouTube. Somebody mentioned that they didn't know how else to reach me. When I go over to the section here, my email is on the bottom right of the screen. So if you want to email me, you can reach me there. Or come to Nintendo Age and check out the forums and the Discord, and there are a lot of people there doing NES programming. It's a fun place to talk to people who are very nice and very knowledgeable. So anyway, thanks for watching. See you Thursday. Have a good night.